attention, please. Maybe with this question. Have you been drinking milk lately? No? Oh, but it's very good for health. What about cheese? Have you been eating cheese lately? Yeah, no? Oh, what about hamburger? Yeah, with double layered hamburger, extra cheddar cheese with some egg on it. It tastes perfect, doesn't it? Yeah, maybe it's good, but maybe it's also bad. Have you thought about this? Maybe how irresponsible this is? How? Why? Okay, well, about this exactly will talk to us today Benjamin Robert. He is a chemist, he's an animal rights activist, and also a biohacker. He's also, I would like to say that, he's also the author of a very famous paper talking exactly about how to turn meth into a treatment for nasal congestion. Please welcome him with a very warm applause.
So I want to tell you that the future is vegan. We have very little choice about this if we want to be able to feed the world and avoid environmental disaster. But you're not necessarily going to have to change your diets. You may not have to give up that hamburger with cheese. And I'll tell you how. First, I want to show you a video from the future, though. I've obtained an authentic video from the future.
Lieutenant Yar was confused. We no longer enslave animals for food purposes.
But we have seen humans eat meat.
You've seen something as fresh and tasty as meat, but inorganically materialized out of patterns used by our transporters.
Sickening. It's barbaric.
Okay, so we're not quite there yet, but there's some really impressive technologies out there that I'm going to tell you about in a few minutes. But I want to tell you about why we should care about this. So I am an animal rights vegan, so I actually care about it because of the animals. There are other reasons, though. So, these are pictures from factory farming in the US. You probably think, well, the US is actually the worst in the world. That's true. We are the cruelest to animals in the world. It's not as bad in Europe. I would still say we shouldn't do it. The thing is that the environmental impact from raising animals is huge, and you actually have a lower greenhouse gas emission from this intensive farming than from pasture raising animals, which is obviously kinder to the animals. But none of it's actually very good for the environment. It turns out to be incredibly inefficient. So if you care about the environment, you should care about replacing animals with something more efficient. And so I'll show you a few numbers. So when we talk about greenhouse gas emissions, we usually talk about generating electricity, driving cars, transportation industry. But actually, it's a pretty significant amount of the greenhouse gas worldwide emissions come from animal agriculture. About 18% of all of our emissions are from animal agriculture. We use 1/3 of the ice-free Earth for raising animals, either for their feed or for the animals themselves. And over half the water in the US goes to animal agriculture. So this is a huge impact. If you look at the environmental impact of different diets, so there's 3 bars for each kind of diet. The one all the way to the left, the tallest one, is our current state of technology. And these other bars are assuming different technological innovations. But you can see that the way we currently eat, there's no level of technological innovation that was predicted in this study, at least, that gets even close to as good as a vegan diet is at the moment. So really going vegan, you have a much lower impact on your greenhouse gas emissions. A few other interesting numbers. This study is showing that if we want to hit our environmental targets, it would cost about half as much to do so if we transition to a low meat diet. So it actually costs less to do this. In the US alone, if we switch from animal agriculture to just vegetable and grain farming, we could feed 1 billion more people than we currently do with the same resources. And actually, I like the study. The name of the study is Redefining Agricultural Yields from Tons to People Nourished per Hectare. And this is a much better way to think about agricultural output. Why do you care about the weight of the food you get? How about caring about how many people you can feed with those resources? And a study from the USDA, which is not opposed to animal agriculture in general, they usually promote it, saying that we probably can't hit our greenhouse gas emissions targets and keep farming animals, basically. We just can't do it. So now for something slightly different. I don't know how many people have seen this movie, Sharknado. It is completely ridiculous. I've never actually seen it, but somehow there's a tornado and sharks in it, and this menaces people. Not realistic, but cows are absolutely the worst as far as greenhouse gas emissions, intensity, resources needed for calories out. So farming cows increases global temperatures. Increasing global temperatures leads to more storms. More storms can lead to more tornadoes. So a realistic threat is the cownado. So watch out for this. Okay, that's entertaining, but this problem's not actually funny, right? 50% of the world's population lives in areas that are at danger of coastal flooding over the next few hundred years. That's a lot of people. We've already had millions of people a year displaced due to climate change, and this is going to increase greatly. There's the coastal areas, but then if you live inland, most people rely on snowpacks and glaciers that are not being replenished, so they're going to experience extreme drought if we keep going the way we're going. So, this affects everybody. It's a really bad problem. So, are we condemned to tofu? Tofu is great. You shouldn't think of it that way. You should eat tofu. You can ignore the rest of my talk and just go vegan now. That's what I would prefer. But if you don't want to do that, there are other options. There's a new generation of vegan food that, which is currently being developed, which aims to either exactly replace meat with something that's the same, that's animal cells, and is indistinguishable because it's actually the same thing. Or there's also some genetic engineering approaches I'm going to tell you about that replace single proteins that are the most important for whatever food you're interested in. And I'll talk about some of those. So the kinds of things I'm going to talk about. First is food science and engineering. And this is not exactly high tech. This is the kind of technology we've been working with for nearly 100 years. It's just using a scientific approach to making better foods. And so any processed food you've had falls under this category: food packaging, food transportation. So this is a well-established discipline. A newer one is in vitro meat. This is where people take an actual sample of animal cells, grow it up in a petri dish, and then harvest it and make hamburger or whatever other meat out of it. I'll talk a little bit more about that. And then there's also the genetic engineering approach, where a non-animal organism gets the DNA from an animal, and we make some protein that we're interested in. I'll talk about some of those efforts as well. Before I go on with those, I want to say, again, there's a lot of great vegan food out there already. These are traditional chef kind of approaches. All over the world, there's really good vegan food. So go check some of that out. But getting back to technology. So food science is basically, like I said, just the scientific approach to any aspect of food production. And for the purposes of what I'm talking about, for vegan replacement foods, it's taking an engineering approach to plant proteins, plant starches, other plant material, and finding a way to engineer that to be a convincing meat alternative. There's some really good ones out there right now. There's good egg replacements already. So Hampton Creek Foods is one company. Bill Gates is one of their investors, and he made the point that we've only explored about 8% of the plant proteins in the world. We don't know what most of the rest of them do, or if they can be used as replacements for animal products. So Hampton Creek Foods went on a search for a bunch of these. They found a specific pea protein that was very similar to some proteins in eggs, and found that they could make some pretty good egg replacements. And mayo is their first product that's actually one of the easier things to replace, but they're doing quite well. But they're using this first investment and sales of these products to make a huge database and explore all of these proteins, or as many as they can. There's also a very realistic scrambled egg replacement. And I found a good Amazon quote that supports my point where a lot of people say that they can't really tell the difference, that this stuff is very convincing for scrambled eggs. So those may not seem that far out there. There's a replacement seafood that is also no genetic engineering, no cell culturing. This is just plants that they've taken and made shrimp out of. So there are reviews calling it insanely realistic. One thing about this, you get to start to think about new things that you can get out of these plants. It's not exactly just a replacement. In this case, there's no allergy problems for most people. Seafood allergies are fairly common. There's a lot of people who have them. So this gets around for most people the allergy problem. It gets around some religious laws. There's this company called L'Haim Sushi that is using shrimp. And a big one for shrimp, child slavery in Southeast Asia is really sort of vital to the current shrimp production chain. And so this gets rid of that problem. Okay, so that's the engineering approach that is a fairly traditional way of doing things. Now we get into some of the really new stuff, such as the in vitro meat, also sort of being rebranded as clean meat. And there's some good reasons for this. It kind of sounds like a marketing term, but it really does have some good reasons you would call it that. But let me describe first how this works. So cells from a cow are taken, and this doesn't have to be invasive. You'll only need a few cells, and you get to grow these cells up basically in a vat. Maybe it doesn't sound that appetizing, but you grow them up, and then interestingly, just like real muscle cells, you don't get the right texture unless you exercise them. So people actually put pieces of Velcro on either side and move them back and forth, and this gives it the correct texture. From there, you get to formulate it into a hamburger. Now, there's a few things, and of course, other meat will be possible after that. Hamburger is the easiest, but you should be able to make a steak eventually once we get really good at this. This is a little bit more complex than some other things we'll be talking about because meat is not just muscle cells. You also need fats. You need some other things. And so you actually need to get these cells to grow together correctly in the right 3D architecture. So this is something people are working on. I don't think we're quite there yet. And also, it's kind of expensive at the moment. Mark Post's first hamburger cost nearly $500,000. Most of us probably are not going to pay that much for a hamburger. Also, right now it requires, at least most of the efforts rely on fetal bovine serum. And even if you don't know what that is, you can probably guess that it is not vegan. Also, Michael Eisen, who actually works for a competing company here, so makes this point that this is kind of disgusting both to vegans and to everybody else as well. But that turns out, I'll say in a minute, it kind of turns out about how you frame the question. But yeah, a lot of people are kind of weirded out by this. It doesn't have to really be that disgusting. When you grow these cells, most people think food grown in a test tube doesn't sound that great. But the way you actually do this is you put this in a big bioreactor that looks a lot like brewing beer. Most people are okay with brewing beer. These cells grow in a very similar way. You don't usually have to exercise beer. We still have to do this, where it's going to need this stage where it's stretched and exercised. But look at this. The batch process can be as short as 7 days. So you can grow up this huge amount of muscle cells in just a week. It can be 10% the greenhouse gas emissions as for the same meat grown in an animal. So there's some big advantages to this. Fast, low impact. And there have been surveys where people have been asked about this, where it's been framed differently. If you say it's grown in a similar way to fermenting beer, would you be willing to try this? A lot more people say yes compared to when you ask them if it's meat from a test tube, would you be willing to try it? So it kind of depends on the marketing a little bit. Oh, and the one other thing, when you slaughter animals, there's always a chance of contamination from some other part of the animal back into the meat. So mad cow disease is an example of this. And I know in the UK a few years ago, there were a lot of bans on importing beef. And I think the EU may have had some as well because of mad cow disease. There's also E. coli contamination from the intestines of the animals that sometimes cause pathogenic E. coli. You don't have that risk in this case. So that's why one of the reasons that people are calling it clean meat is because you actually have a much lower chance of contamination. So this seems kind of far off, but actually maybe not quite so.
This is the first time a meatball has ever been cooked with beef cells that did not require a cow to be slaughtered.
It tastes like a meatball.
So there has actually been, there's this company, Memphis Meats, which has made, they've made a meatball, but it's supposed to be very, very realistic. They are scaling this up now. It's still fairly expensive. Their price right now is supposed to be $18,000 a pound, down from $500,000 a hamburger, but it's the right direction. But Mark Post, the one who made this $500,000 hamburger, says that his burgers are now $11 a patty. He's not actually selling them, so we won't know until they're actually on the market, but he claims that that's where you can get right now. And he has also said that he has a replacement for the bovine fetal serum. I hope all that's true. We haven't actually seen proof of that yet, as far as I know. But I think this is still a few years off before it becomes a real mainstream thing that you can go out and buy. But the technology is moving there. So I'm going to talk about a slightly different technology now, one that I work on for one of the projects that I work on, genetic engineering. And I know this is a slightly controversial topic, especially in Europe, but specifically I want to talk about transgenic organisms. This is where you take the DNA from one organism and put it into another, hopefully for some good reason. Let me explain the process a little bit. This can be, it's actually not that hard to do. I do this at a hackerspace in Oakland, California. And basically, you have to start with a DNA sample. Well, from humans, you can get a DNA sample from spit or scraping a little bit from the inside of the mouth. You then take this sample and you get the DNA sequenced. We don't do this in my lab. It's kind of hard to do with inexpensive equipment, but it's not actually that expensive to have DNA sequenced. You can send it out to commercial services. Anybody can do this. And it's not that expensive. Once you have that sequence, you put it into your nice modern computer where you need to re-optimize the DNA sequence for the organism that you're putting the DNA into. So if I have a sequence from a cow, that exact DNA sequence will not make the same protein in yeast, so we need to do this optimization. The interesting thing is that there are free online tools that allow you to do this. You say, this is a mammalian piece of DNA, and I want to grow this protein in yeast. You can find online tools for free that will do this, and they will check your work. So this is actually pretty accessible, not very hard to use. This part's a little bit harder, takes a little more practice, but again, there are free online tools that will help you. You then get the DNA synthesized. You can do this as a commercial service. Again, not that expensive. You can do it for a few $100s. You put the DNA that you're interested in into this circular piece of DNA, and you get to put other instructions on here. And this is really important. You get to do a lot of cool things. One thing you can do is tell the organism when you've made the protein, kick it out of the cell. So if you have yeast that has one of these plasmids in it and you're making a protein, the yeast will then kick the protein out of the cell, and then you get to collect it much more easily than if you had to grind the yeast up to get it out of the cells. You can put kill switches into this so that if this escapes from your bioreactor, it cannot spread in the environment. So this is important also. You can consider it a safety feature that you can program in. From there, this is a picture of bacteria, but this works in yeast and other organisms as well. You get your circular DNA, the plasmid, into the cell of the organism that you want to produce your protein. If you leave it as this standalone piece of DNA, it will produce your proteins. You can also recombine it with the genome of this cell. If you do that, then future generations will also have the ability to make these proteins. So that's generally what you want to do if you're making a large-scale product. Again, when you scale this up, it's very much like brewing beer. In fact, if you're working with yeast, it's almost exactly like brewing beer. Of course, it needs nutrients. Sugar is one of the main things you have to feed these things, and this is where, in this whole process, most of your greenhouse gas emissions come from. Of course, sugar takes some energy to grow, takes some resources, but this is a very small amount of resources compared to growing an animal. So this is still a big advantage. You then have to separate out, and this can be one of the harder parts of this whole process. You need to separate your protein to have the pure material. And this actually is what people often spend the longest optimizing. But once you've done that, you have your pure protein. You can go on and make your food replacement. So this is the project I work on, Real Vegan Cheese. So we're a bunch of biohackers in Oakland. We are engineering yeast to make milk proteins so that we can make cheese that is identical to real animal cheese because it's got the same protein in it, but came from yeast, not from animals. And so our process is very much what I just described, where we didn't do this thing where we sequenced the genome ourselves. We found this already in a database. We got the DNA synthesized. We put it into yeast. We get protein out, and then we will formulate milk and make cheese. We haven't actually gotten to cheese yet, but this is the idea. We picked a particularly hard project in that most of the other things I'll mention are single proteins that people are using. We're actually doing something. Casein is a complex of 4 proteins. It's got a lot of other stuff in it, and so it turns out that we have a lot of work to do to get this whole micelle to reform. But this is really what makes cheese cheese. It's this complex protein that we're synthesizing. I'm not going to go through all the details here. I gave a talk at camp that if any of you want to see a lot of details on this project, can be found in that talk. So I'll go just very briefly through our progress. Basically, we've made these proteins in very small amounts, we're pretty sure, but we had a lot of trouble identifying that we made the right ones because yeast makes other proteins the same size, and our inexpensive method only tells us the size of the proteins we're making. So we went back and redesigned the protein to have a tag that will make it easier to find. We're also looking for other yeasts, not baker's yeast, that will give us higher output. But one important thing, most of us are not biologists. We don't put a lot of time into this, but we really want it to work. So we're actually just filed for a grant where we are trying to get some money to hire people to do this, but we're still going to keep it open source. So if we have people paid working on this, we'll still release all the data as we get it. So what else can you do with this? It turns out it's not just food. You can make leather. Leather is mostly collagen. And you can get yeast to make collagen, and you can make very realistic leather. There's a company called Modern Meadow in Brooklyn that is doing this. And another important thing, as I mentioned before, you get to optimize past just replacing the animal product. They say that they can make leather that's actually better than animal leather for many strength tests for the way it feels. You get to engineer past what evolved. Another interesting thing that's not exactly replacing a current product. This company, Bolt Threads, is making spider silk garments. And growing spider silk in yeast is probably easier than farming spiders. I haven't tried myself, but I think I'd go with the yeast. So there's another egg replacement, and this is a genetic engineering one, again in yeast. In egg whites, there's really one important protein, albumin. This can be made in yeast. And again, you get to engineer it to maybe even be better than egg whites. But another important thing, a couple years ago in the US, a very large percentage of the egg-laying hens died of avian flu. There was this huge outbreak. All these hens died. Egg prices went up 80% over a few months. Turns out that yeast is a much more secure supply chain. Disease is not likely to wipe out a bunch of stuff that you have in these fermenters that are separated from each other. You're not going to spread diseases easily, so this is very attractive from that viewpoint also. You also are not going to get salmonella. And the other thing is that intensive bird and pig farming operations are where most human flus develop. They're spread from farms, largely in China, into human populations. That's why it's called swine flu, bird flu, avian flu. They have this quote that's not exactly appetizing, talking about their baking and binding applications team. But again, they're just saying that they can make something that's even better than egg whites. You get to optimize past the animal product. Another thing, gelatin. Again, you can make it in yeast. It's usually made from animal bones and skin, but you can make it in yeast instead. And some things you might recognize, Jell-O, marshmallows. If you take anything in a gel capsule pill that doesn't say that it's vegetarian, then that is gelatin. It's also used as an additive in thousands of processed foods. So this is a very common thing. Something cool, this company made mastodon gummy bears. They actually took the genetic sequence from mastodons. They have been sequenced and used it to make gummy bears as if they had ground up mastodon bones. I'm pretty sure this is the only way you're ever going to have a mastodon gummy bear. So again, you get to do completely new things with these technologies. So with this genetic engineering, I haven't really talked about meat yet. And so this is the last thing I'll talk about. Where does cooked meat come from? The flavors, textures. Well, of course, you need the protein. You need the fat, as I've already said. But something else that's really important if you want it to be a really realistic flavor, you need basically blood. You need the hemoglobin-type proteins. So these heme proteins have a very specific flavor themselves, but something else really important they do. They catalyze these reactions. So when you cook your bulk proteins plus your heme-containing proteins together, you get, I gave just a few examples here, there's actually thousands of small molecules that are made, and this is what meat flavor is. So if you want to make your meat taste really like meat, you need to make these things. Heme-containing proteins occur almost entirely in animals. It turns out that there are some plant sources. So there's a company, Impossible Foods, near San Francisco. They're making a burger that is mostly made of wheat protein. And this is interesting because wheat protein has been used for over 1,000 years in China to make meat substitutes. It's sometimes called seitan, but it has other names in China. It makes a very good texture. The flavor, it has very little flavor, but the texture is pretty good. So Impossible Foods also uses coconut fat. It turns out that animal fats are not really that unique. You can use a lot of other substitutes and they're okay. But their innovation really, they take engineered yeast that doesn't show up in the final product, but they have engineered it to produce a heme-containing protein. So they basically get blood out of yeast. And so putting all this together, and there's a bigger picture of all their ingredients. That's what goes into their burger. There's a picture of what it looks like cooking, and there's a picture of the of a burger put together. I've had one of these. It is disturbing, I think, to me because I'm a vegan and it tastes like a real hamburger. But also people who eat meat have largely said, some people say it's not quite there, but most people say it's a pretty good burger replacement. So this is very, very similar, and it is because of that heme catalyzing those reactions. They put a lot of work to getting the texture right, but really the flavor is that heme protein that came from the yeast, their plant blood, as they call it, making these same reactions that make these small molecules. Okay, so you can make all these different kinds of meat replacements, other animal product replacements by genetic engineering, by growing individual cells. But I've mostly, besides my project, the Vegan Cheese Project, I've just been telling you about, these are all startups I've talked about, actually. And so, that makes you think, well, okay, so is capitalism going to solve this? And not entirely. But it depends on what question you're actually asking. So what capitalism is good at is if you have a new product and you think you can make money from it, making something that fits into that market, capitalism is really good at. There's another part that I haven't been talking about, and that is that we already actually make enough food. It's got too high of an environmental impact, but we're not feeding everybody. Capitalism is not going to solve that. So that part of the problem, nothing I've talked about here is going to address. So again, we could all go vegan now and have a much lower impact, but I suspect that's not going to happen, which is why I'm excited about these projects. Basically, what they will allow you to do is, if you're not willing to change your diet, you don't really have to. There will be things that probably, whether you think or not now, most of you will probably eventually be convinced by some of these products. The other thing is that they will be cheaper. And once they're cheaper, and if you think they're good enough, that's where people are going to start adopting them. And that's it. Thank you.